Everyone, January the 10th. Alright, I don't know what happened, but my gum is so swollen at the moment. Like close to my molar on the left hand side. It's so swollen that it's hard for me to even eat. It's painful. It reminds me of the time when I had an ulcer. But this one is, I don't know what happened. Every time I close my mouth, I have to be careful. Because otherwise I might bite into it and it'll cause even more pain. Yeah, I kind of know the reason for this, but to solve it, yeah, I just need more sleep if I want to solve all this. Like my body is very inflamed at the moment, very high inflammation at the moment. I can feel it. I think the mouth thing is just when it's the inflammation just kind of go out. But this is the change to my training program. Like my new program has a very high volume, so every day is just grinding through all this. I mean, okay, honestly, the weight is not that heavy. Okay, it's only like 70%, but just every day I have so many volume. I mean, my body feels fine. You know, the muscle is a little bit aching, but it's within expectation. The joints feel good. I mean, I hurt my hand a few weeks ago, and then the hand is even healing. But man, this mouth thing, this gum thing, is really making life quality so low. All right. Anyway, let's not talk about life quality, but talking about this problem. Construct k palindrome strings. Okay, this is a new problem, which is good. Given s and an integer k, return true if you can use all the characters in s to construct k palindrome strings, or false otherwise. Can you use everything to create two? We can construct two palindromes using all characters in this. The possible combination will be Anna and you can move them around. Oh, that makes them so much easier. So basically, we'll count the frequencies of all the words, right? And we will only allow, because each palindrome can allow one odd number, right? So you get your k, so you know you have how many palindromes you need, right? And then you just need to find, because all the even ones can form palindromes by themselves, right? So okay, first of all, you need to check how many letters there are. If they are smaller than k, then it's a false, right? If it's equal to k, that's immediate a true. If it's more than k, then you need to do a little bit count, right? And in fact, you should do a little bit count and then count how many uniques you have, right? And if the number of uniques is equal to the k, right? You have a number of uniques is equal to the k, then it's always going to be true. If the number of uniques is smaller, right, then what we need to find is, because I was initially thinking, we need to know how many have odd counts, right? How many has odd counts? Hold on. If I have odd counts, so a bit like this, right? We can create, the easiest way to think about this is we can create a giant palindrome, and then we have the remaining is just single letters, right? So we just need to see if we can create a giant palindrome. And to create a giant palindrome, we can say we need to, so we have the overall frequencies, right? And if you have even number, we don't worry, because you can definitely fit into a palindrome. So now we have the number of odd, right? Odd frequency letters. And for all the odd frequency letters, we can take them out. Take one out and become even, so it's good, right? So you can, so if we have equal to k number of odd, then we can, now k minus 1, right? If we have, if we have a k number of odd frequency, we can take k minus 1 out, and now we can form. That's good, right? So if we have smaller than k number of odds, which is also good, right? Smaller than k number of odds, we can take them, right? We can take them, and so if it's smaller than k, we can take them all. Okay, we take them all, and then we'll have whatever that number will be individual, right? And the remainder can form a palindrome. So if I need even, so I can take like 2 more, then it will always work. If it requires 1 more odd, I can take 1 more odd, and it will always work. So if the number of odd frequency is smaller or equal to k, it will always work. So now we need to see the number of odd frequencies larger than k. Okay, if it's larger than k, I think it is still a possibility of success, but you need to think more, right? It's larger than k, which means because the whole purpose, right? If you have an odd, it might still be possible depending on the number of even pairs, a number of evens, right? Because I can have something that's, it can be k equals to 2. Well, I'm gonna say k equal to 1, right? K equal to 1 if it doesn't work. K equal to 1 if it doesn't work. Hold on. Can I do with like more than 1? So like we have A, B, C. Let's say k equal to 2. Okay. I have A, B, C, so I have more, and now I have the rest is all even. Okay. So I can pack the even around, pack another even around. Yeah, then we always have 1, because the odd ones can only form by itself. So, okay, yeah. We just need to count the number of odds. And we count the number of, I feel like we have some situation we haven't considered. We count the number of odds, right? Because each odd must form its own palindrome, right? So the number of odds determine how many palindrome is required, and then it doesn't really matter what the remaining are, because the remaining we can always just attach to them. So as long as we have enough letters, then it will always work. Okay, that I can stand behind. So first things first, we shall do is, I wonder if I can do, no, I think you have to use new. I don't know, let's just vector it. Counter, let's call it frequency. 6, okay. Char C of S, frequency C minus A, plus plus, for in I 0, I smaller than 26, I plus plus, K minus equal to, can I int this frequency I is equal to larger than 1 to 0. Oh, I don't have to, because I'm just going to do a mod, right? Mod 2, right? We're going to return k larger equal to 0. $1,400. The number of odd frequency letter determines the minimum palindrome. The minimum palindromes required from us. Thus, if the minimum it's not minimum, it's the lower bound, the lower bound of palindrome. How many palindromes must be formed, right? How it must be formed to use up every letter in S. Thus, if this lower bound number is bigger, right, than k, we are not able to form just k palindromes. Required to form more. Alright, so we will run this and so first we'll see if it works. Looks like it works, then we'll submit it. And it's wrong. I am surprised. Output is true. Oh, you just said. Oh, okay. I just said don't forget. If s.length size is smaller than k, return false. You said it, right? You just said it before you even start, and you forgot about it. I am ashamed. Truly ashamed. 8042. Yeah, that was very very bad. Count odd frequency. That should be it. Bit manipulation. Oh, wait, what? Update the bit mask for each character in the string. Oh, yes, if it's odd, it will remain 0. If it's even, it will be 1. Then we just count the number of set bits. Why do you do it twice? All right, so did you upload this problem? I don't think so. Hey, no, it's not what I want to do. Oh, the confusing UI, huh? All right, let's try this just a little bit. Okay, I think we have the solution. We know what is needed, right? we need a task. I remember it's going to be a map where we'll put, because we need to remove, so the task ID, okay, we'll put a task ID in the map, and the value will be, what is the value? Task ID, user task ID, and priority. We'll add task ID, priority, and I think what we say is the task ID. Can I assign? User may be assigned multiple tasks, but can a single task be assigned to multiple people? Can a single task be assigned to multiple people? As a task with a specified task ID and priority, it is guaranteed that the task ID does not exist in the system. So the task ID is unique. So we'll have a map of task ID to user ID and priority, right? And then when I add it, we'll add the priority and task ID to a priority queue, right? And we'll also add it to the mapping. And then when we edit it, we change the mapping and then we push a new task ID to push a new element into the priority queue. When you remove, then you just remove the task ID from the mapping, right? It's all fine. It's all straightforward. Execute top will execute the task with the highest priority across all users. So that is the top of the priority queue. If there are multiple tasks with the same, execute the one with the highest task ID. So I don't even have to change or use a custom comparison, because in C++, priority queue is by default a max heap, right? So I just put them in the good order. So the first one pop out, then I need to go into the mapping to see the task ID if its priority is correct. If it is correct, then that must be, then that must be. If it is not correct, then I pop it, which just means this task is no longer useful, or if the task ID doesn't exist in the mapping. All right, so that's pretty straightforward. We can technically we use, we're gonna use Python for this. Okay, let's use Python for this. Okay, Python for this then changes everything. No, it does not change everything. It changed something. All right, so we decided that this is going to be Python, which is fine. So initialize, I just need a map, right, which is a dictionary. So what I can say is self.map. Oh, I cannot use map. Self.task ID. Probably can. Yeah, I think I can. Equal to for, what's that? The user ID, UID, TID, and priority. So UID, TID, priority in tasks. Okay. So what we're gonna do here is task ID shall equal to priority and a UID. All right, so this will get a map and we'll add it. So how do we add? Oh, we also need a priority queue. So let's say import heap. Right, so we say self dot max heap is equal to this. Huh. Okay, and then we say for, we can say for again. I don't need UID, just TID and P in tasks. I can say self.max heap. Nope. I think it's heap Q. Heap Q. I haven't used it. See, maybe it's important for you to keep, practicing Python. Otherwise, heap push. Otherwise, you're gonna forget. Max heap and, well, priority first, task ID second. So there are two ways. One is to put negative and make sure everybody is positive. Yes, everybody is positive. So I think we can do negative to achieve the max heap. So we're gonna add one. So we basically say self.map task ID so equal to priority and user ID. Okay, and then heap q dot heap push self dot max heap again minus priority and a minus task ID. Edit. Okay, so we say if self.map task ID 0 is not equal to new priority. Is not equal to new priority, then self.map task ID 0 or equal to new priority and self dot heap q dot heap push self dot max heap. We're gonna push new, which is new priority and task ID. But if they're equal, then we don't have to do it again. Remove. It's guaranteed, right? We don't have to check. It's guaranteed that it exists. Oh, and we just delete del self.map map, yeah, task ID, yeah, we just delete it. Execution while self dot max heap, right, and self dot max heap 0 is your, now 1 is your task ID, right? 1 is your task ID, so self dot map. Okay, this thing, but it need to be negative, right? If what is the map? The map priority is 0. Okay. If this is not equal to max heap. Wait, hold on. Why you say max heap? Dude, this should be 0. 0? Man, this thing is complicated. Yeah, 0, 1, and then 0, max heap 0 and 0. Because 0, 0 on the heap is the priority. So we're comparing the two priority. And we say if the two priority is not the same, then heap q dot heap pop self dot max heap. So we don't want it, right? So we just keep going until we hit someone that is good. Okay, that is good. And then we'll execute it. Okay, execute it. It's removed from the system. Return the user ID. So we can say TID shall equal to that's a TID, no, priority and TID self heap q heap pop self dot heap max heap. So we get the task ID, and then I say delete self dot map Oh, don't delete it. I can say return self.map.pop TID and user ID is 1. Need annotation for this. Okay, so max heap is going to be a list of integer. Okay, let's see if this one works. Okay, there's some error. Wait, what? Oh, I think I know what happened. Yeah, when you do push, you need to do negative. Negative. Okay, that's one bug. And another bug is, it looks great. Another bug is, there should be a negative. I think I'm almost done with this. Actually, no, this also needs to be negative. So many negatives. It's still cannot assign. Okay, so I probably need to just go. I'll pop this one. Yep, that one looks nice. So I'll just say straightforward implementation. Very similar to Dijkstra. All right, we'll put it there and let's see if it works. We have problems. All right, let me feed my cat first. Oh, I think I know why. I have a suspicion. Okay, so I need to change the code a little bit. It's it's not gonna work. All right, not 100% sure, but I think the reason that it fails, I didn't check if the map contains. So I think I'll do some to make this more readable. Okay, right now it's really not readable. All right, so what do we need? We need to get both, right? So I can say negative p and the negative tid max keep 0, right? So we get them out and we say if negative tid is in self.map and self.map negative tid 0 is not equal to negative the priority, then under this condition, then I'll pop. Otherwise, we don't. And here, I think naming it next negative TID is better. So it's kind of annotate, right? It's the negatives. All right. So now if we try it, we'll add this test case. So I have two test cases. We go through this thing. Oh, I forgot it should be an else. Forgot to break it out. So that's kind of stupid. Huh. What is that? Still not right. Hold on. I remove and execute. Oh, I didn't really check. Oh, return -1. Because I remove it. Then okay, so if negative TID not in self.map, or it's in but it's, then we will always pop, right? So eventually we'll say if there's nothing, right? So if self.max heap, then we do this. Otherwise, we'll return -1, which just means there's no task to be done. Oh, not in self.map. Or it's in self.map, but its thing is not correct. Then we'll pop it. Otherwise, it's in Oh, it's negative. Darn. It's negative. That's why I kept failing. This one I think is correct. There we go. This one's correct. I am wondering if there's any better solution. So this is 647, 30.49%. Hash map plus set. Map and priority queue. Oh, you click this. This is a map and priority queue. Hash and set. Okay, so maybe this can make it faster, right? So it finds it. What the hell is this T? Set. And then raise it. Oh, I think the map is ordered map or something like that. It's a map. It's a task ID to user ID and priority. Where did you get? Is set keep order? What? Because all I see is just see this one dot insert. Yeah, you see, you just do minus minus, get the last one. So I think what it says is when you edit, you can just do this. You don't have to. I mean, yeah, we have to push it in no matter what. Oh, but because it's a set, you can find it and change it. But it's not possible for priority queue. Okay, that's fine. Like I said, it's not really that hard, this one. Next question. Yep. I'll leave it here. That'll be it for today. I will see you guys tomorrow. Adios.